Greetings, STEM tours. Welcome to your last lesson of the semester. For your bell ringer today, what I want you to kind of think about is, if we start with two similar triangles, and actually just starting with one, for instance, this one here. Okay, if we start with triangle DEF, what's going to happen if I stretch or shrink this baby down? Okay, well, look at this. If I slide, this is basically the same triangle. I just shrunk it down. You should be able to notice the top angles are the same. We've kind of noticed this pattern already. The left side is the same. And you'll notice if we slide it over, those two angles are congruent as well. Okay, so a lot of times we're going to have similar triangles that have all of these patterns existing. And what we haven't talked about is how do I write similarity statements. Now, first question on yesterday's homework asked about this, so you'll probably want to go back and make that revision on the homework before you turn that into me today. Okay, so similarity statement is going to be very simple. We're just going to name our triangles, and I'm going to name the one on the left ABC. As long as we use the three vertices, it doesn't matter what order we go in. This little squiggly symbol means is similar to, and we'll say that triangle ABC is similar to triangle, if we go in the same order, ABC would match up with DEF. Okay, now for the similarity statements for the sides, I don't even have to look at the picture. I'm just going to look at that statement I wrote and pick two corresponding or two adjacent side letters, which would be AB. And if you look at what that matches up with on the other triangle, the first two letters are DE. And so we're just going to basically do, that same pattern. Sorry, I hit the wrong key. That same pattern for all of the sets of sides. Goodness gracious, my paper's not clicking correctly when there we go. Let me get rid of that. There we go. All right, so AB and DE would be proportional sides. And then if we slide this down, BC and EF, if you look back at your picture, BC and EF would be proportional, as would the first and last letters, so AC and DF. So you're just matching up the three sides of the triangle. Okay. What is going to happen every time we have similar polygons? The angles, the corresponding angles, will be congruent, and the sides are proportional. So we have observed this many, many times this unit. We just haven't formally recorded it. Okay. Lots of experience to learn that from now. Hopefully it's not just facts you're writing down. Now you have some experiences to build upon. Okay, so what I just wrote down a minute ago, yeah, all of these things definitely are true when we see similar polygons. But do we have to know all of that? Well, in fact, you don't. So if you have two triangles and you're trying to figure out, are they similar? Really, all we have to know, this is a question mark. I'm just saying, I'm questioning whether they're similar. If I'm wondering if these are similar, in terms of the angles, all I would need to know is that two of my three angles on the triangle are equal. And the reason is, let's just say this is, 50, and this is 50, and this is 80, and this is 80. We know triangles have a sum of 180. So as long as two of those are given, we know the missing angle here to add up to 150 would have to be 50, or to add up to 180 would have to be 50. So since the angles are all the same, yeah, that definitely makes them similar. So angle-angle similarity says if two sets of corresponding angles are congruent, then the two triangles are similar. Every single time. It doesn't apply to every shape. It just applies to triangles. So these rules we're looking at only apply to triangles. Okay, side, side, side similarity looks something like this. We'll have two triangles. And I'm just going to label the sides as A, B, C, D, E, and F. As long as all three sets of sides are proportional, in other words, have the same scale factor, then the triangles are similar. So this one says we don't even have to know anything about the angles. We should just be able to match up. All right, so whatever we multiply by to get from A to B, that has to be the same as what it is from B to E, the same as what it is from C to F. So the easiest way to check it is to write some ratios and see if they reduce to the same value. So we'll do a few of those in just a minute. All right, the last one, side angle side, looks like this. We have two triangles again. And if they're similar, they're going to have one angle that's congruent. And then these two sides, say the ones that surround the angle. So in this scenario, side angle side similarity would say, if we know, I'll just call this J, K, L, M, and O. So in this case, if we know angle J is congruent to angle M and A over B, so the left side as a ratio equals the right side, as long as that happens, then the triangles are similar. Okay, so very general concepts. I want to do some applications. And what you'll do after you get done with these applications is you'll try the last, you'll try the last page on your own, and I'll have you bring that up, and I'll get you some feedback on it to see how your comprehension is on these topics. Okay, so we'll do a couple together. Let's see. First one gives us two triangles. And notice our only three choices, well, technically four, I guess. We're checking side angle side, side side side, and angle angle, or it'll be none. Okay? Caution, caution, caution. Don't assume this is the same side 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 we learned about during triangle congruency. Side 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 on this unit looks at corresponding sides, and they have to be proportional. So here's what that means. We look at 2 and 4, and I look at that scale factor. I'm just going to write it as a proportion of big over small. 4 over 2 should equal, same thing when I match up the next set of sides, should equal 3 divided by 1.5, which, if you look at the third set, 2 over 1. If I divide each of those fractions, I get the same answer of 2. That means these are proportional by, similar by side, side, side. And that's because every side on the left triangle was multiplied by 2. And it just has to be the same number. It doesn't have to be 2. Okay? Let's check out the other one. So on number 2, we have some angles provided. And it looks like we're probably going to be narrowing it down to either angle, angle, or that they're not similar. So let's see what we can observe. In each triangle, they only give us 2 angles. So let's try to figure out the third one. Well, 42 plus 70 is 112. So that means if I subtract from 180, that means 68 degrees is left for the top angle. Well, if we correspond the angles here and compare those, we have two angles that are 68 degrees, and then we have another set that's 42 degrees. Well, that's angle-angle similarity. So when I write my similarity, I actually should have over here put similarity, so we don't think it's the congruent ones from last unit. So this would be angle, angle, similarity. All right. I'm going to have you guys do the next two, but don't bring them up until after I do the first two examples here, okay? When you bring your paper up, you're going to show me number 3 and 4 on this page and number 3 and 4 on the other page, okay? So let's do these last two together so you can kind of get a little bit more practice. All right, so are they similar? Well, let's see. We have two angle. Let's see. On the first one, we have an angle. So that makes me think we're either going to check angle, angle, or side, angle, side. So angle, angle means we need to know two sets of angles are congruent. And in this case, we have the hundreds, and then we have this other angle that we don't know the measure of it, but we know they're congruent. And so yes, they are similar by angle, angle, similarity. That kind of looks like angle, angle, side. Angle, angle, similarity. And so the scale factor would be just a ratio of the two sides. So I didn't tell you which one to write first, but since it's different units, we'll say 3 feet over 12 inches, which if we get it into the same unit, that would be 36 inches over 12 inches, which reduces down to 3, or 3 to 1. Okay, so our scale factor here is 3, or 3 to 1. Our similarity statement is going to name the triangle. So we'll say triangle QPR is similar to triangle. And if we go, again, mirror image on the other one, Q corresponds to A. So A, P corresponds to T, and then R corresponds to S. So that's your similarity statement. All right. Number two. Are they similar? Well, let's just check. We have some parallel lines, so right away I notice that these corresponding angles are congruent and these corresponding angles are congruent. So yeah, these definitely are similar. I'm going to say, since they have two similar angles, this would be angle, angle, similarity. The scale factor, well, if you draw them separately, the little one, let's say this is 3. If the little one has an edge of 3, the full right side on the big one would be 6. So our scale factor is either 1 to 2 or 2 to 1. It's basically twice as big. Similarity statement, again, we're naming our triangle, so I'm going to go top, left, right. So that would be triangle JRM, and then that's similar to top, left, right would be JAP. Okay, your job is to complete numbers 3 and 4, bring them up to get some feedback, and then we will give you directions independently as you finish up with your practice problems.